So in this presentation, we're going to give you an overview of where we want to do, what we want to do with monitoring in GitLab. And to be specific, it's going to be centered around Prometheus. And the reason that GitLab will add more and more Prometheus capabilities is that we figured out it's needed to do continuous delivery right. So GitLab, you can work on code together, you can do CI, and you can deliver. You can push code to staging, to production, do review apps. And we learned that to do that effectively, you need feedback. When you deliver something into a black hole and don't get feedback, that doesn't work. So, and that feedback is going to be monitoring. So we're going to bundle Prometheus with GitLab and make sure that it has an awesome, awesome monitoring experience. And because we want GitLab to be great for cloud native apps, it's going to be great for when you run in a containerized environment, but Prometheus also runs fine on virtual machines and bare metal. So it's going to be great for everything. And we want to give you a taste of what you can expect, also to get your feedback about where we should be heading, what changes you'd like to see. But also, it's a very abstract thing, so we wanted to give you an early impression. And currently, we're building a Prometheus team at GitLab. We have 4 people now, and we're still hiring. So if you are very familiar with Prometheus, apply as a Prometheus engineer at GitLab. But for now, let's present the vision. Here to present it is Mark Pundsack, our head of product. And Mark, I'm super excited about this development. So take it away.
Great, thanks, Sid. And thanks everyone for joining now. Just to level set, this call is to go over a first draft of our vision for monitoring within GitLab, a version 0.1 of the vision, if you will. I'm presenting it so Sid and others can ask questions and critique it and to share more broadly. If you're looking for a polished presentation about a well-defined product, this might be the wrong place. So I'll start by talking about a potential MVP, or minimum viable product, and then discuss future directions, and finally open it up to Q&A. And if you want to play along at home, here's a link to your personalized buzzword bingo card for the presentation. So the first step is to add Prometheus to monitor GitLab installations themselves. I won't go into details here, and I believe Pablo will be giving a talk about how we're using it. But in short, Prometheus is an open source monitoring solution. We've been using it internally here, and we're going to bundle it up so you can use it to monitor your own instances of GitLab. Here are a couple screenshots I cribbed from some of those issues. Again, I'm not going to go into detail here. These are fairly traditional, if not ugly, dashboards using Prometheus and Grafana. But we can plug in anything here, and it's a really powerful framework. I kind of tongue-in-cheek called this MVP plus 3, but after some number of iterations, the next major step is to use Prometheus to monitor end-user applications, ideally providing a New Relic-like experience. Maybe it's more accurate to say Heroku-like monitoring experience. New Relic does tons of things we won't touch for a long time, if ever. I believe there's always a dedicated place for monitoring that goes deep. Our unique value won't be in the deepness of the monitoring, it'll be in the integration of monitoring into the rest of the experience. That may not be apparent in the initial release, but will definitely show up later. Initially, we'll focus on Kubernetes because that's where we're placing a few bets, and installing Prometheus into every permutation of hardware is just too much to tackle. So to keep scope smaller, we'll focus on Kubernetes. We'll start by measuring throughput, latency, or response time, and error rates. I'm calling this response monitoring. And it's the highest value we can deliver that works for monitoring any web stack. But measuring resources, such as CPU, memory, and I/O, might be easier for an MVP, so I'm keeping that open. Kubernetes may make some parts of this easier and some parts harder. I don't believe we should do all of this for an MVP, so my preference would be to focus on the web response side of things. The thinking goes, if one of the resources are constrained, say memory is entering swap too much, then that will show up as latency in the system. So I'd rather observe the material impact to the user directly. Unfortunately, that means you don't see anything until it's already an impact. And knowing that latency is bad or error rates are up doesn't really help you debug the situation. and that's where resource monitoring can be useful. But still, as a first step, I want to know how many users are impacted and then find a way to debug it. At which point I may very well fire up New Relic to do more powerful analysis. So to show how we're thinking of integrating monitoring, here's a merge request. It's already been merged and deployed to production. Because we've got monitoring, we noticed that memory usage increased right after the deploy. So we put a message right on the merge request. Let's zoom in a little bit more. We see the alert plus some summary information telling the memory usage increased from 114 megabytes to 127 megabytes. And a little spark line so you can see it graphically. Maybe we'd add a % increase to make it more concrete. Of course, we'd also send an email notification of this alert, so the author of the actual changes will know about the impact. That way, it's not just an ops problem. The person or people most likely to be able to deal with it know as soon as possible. Now let's click through and see more details. Now we see something a little more traditional. This is an early mock-up of how a monitoring dashboard could appear. A note, even in this early stage, we've got lines showing when deploys happened to help identify code changes that impacted performance. Maybe hovering over them would show a list of merge requests that were included in that deploy. This dashboard would be available for all of your environments, production, staging, and review apps. Or maybe you'd only want to install it for production environments. I'm not sure yet. The point is that monitoring is an essential part of environments, deployments, and merge requests. This is a screenshot cribbed from New Relic, but I can imagine some of this information showing up in our deployment history pages. We've already got a list of deployments and what code was in them and who was involved, but tying into monitoring could be a nice place to put it all together. So switching gears a little bit, the future holds an infinite set of possibilities, but I'd like to talk about a few directions that I'd like to consider moving into. First, there's more to flesh out in response and resource monitoring, covering whatever we don't ship in the MVP and going beyond. Then there's status monitoring. Think Pingdom, which tracks whether your app is responding to a certain health check, an HTTP request, to know if it's up or down, and then alerting on that, and of course reporting monthly uptime or something. The linked issue there describes an MVP that just checks a URL after each deploy to see if your merge request booked the server or not. I have no idea yet what role Prometheus may play there, but it's all part of the broader monitoring scope. Then there's broader application performance monitoring, which really is a superset of these other pieces, but I'm breaking it out to differentiate monitoring that usually requires your code to be instrumented with a client library installed in your application, like a gem file or an NPM module. Generally, it's language, framework, and stack aware, and can analyze code paths and even profile database SQL queries. The next level most APM companies go to is end user experience monitoring, measuring the latency at the browser. So it includes the entire trip over the interwebs, and including the time to finish asynchronously loading all JavaScript and actually rendering the page. This gives a truer and often much scarier view of the performance of your app. Then there's user metrics and analytics, clicks and flows and funnels. And lastly, we've got user-defined or business metrics, like signups, conversions, revenue, or really any action that you determine is important for your business success, or just fun to watch. Entirety of several monitoring industries here. Obviously, we're unlikely to be best of breed in all of these, at least not in the next release or two. So again, the focus really is how we can provide the biggest bang for buck, the 20% effort that delivers 80% of the value, and really leverage our unique value. And that's in our deep integration, making everything easier to use because it's already there, and more impactful because it's integrated across the experience. Anyone can show a graph of performance where you see that deploy 123 of merge request XYZ caused a problem, but alerting right on the merge request itself, right after deploying it, and emailing the authors of the actual changes about their impact. Well, that's just the tip of the iceberg of how monitoring could permeate the developer experience. Now let's go in a different direction and talk about something I'm calling deploy monitoring. Deploys aren't just binary pass-fail, and they're not instantaneous, but we currently kind of treat them as if they're both. Deploys can take significant time, going through many different states and across many containers or servers. Being able to track and control and debug that complexity is pretty important, especially for larger organizations. So here's an early mock-up of how we could do integration, this information over into our environment view. On staging, you see that the last deployment finished, but production has a deployment that is ongoing. Each square there represents a container managed by Kubernetes. Hovering over each one shows the service name, the server name rather, and its current status, or container name, I should say. Clicking through might show more details about that container. Since this is in the environment list, we also see our review apps, but we've hidden the deploy status by default since it's less important for review apps. For any of these environments, you can click through to the monitoring dashboard I already showed. There's a little icon there that looks like a graph. Now, deploy monitoring is a rich area with lots of opportunity for growth. Here's an image of someone else's deploy board that shows a Slack notification of a staging deploy and mentioning everyone with code in that change, so they can go and just check their changes. Here are some other ideas I want to explore. First is incremental rollouts, where you deploy new code in batches. Say if you've got 100 containers to roll, you'd deploy 10 containers at a time in 10 batches until all 100 are done. Closely related to that is a canary deploy, where you deploy to a few containers and then stop while you wait some period of time for performance statistics to prove that there are no problems. Maybe you even do some manual tests on just those containers, although really that should be done in staging. And then there's blue-green deploys, which has a few definitions, but the one I'm using here is where you have all of your traffic going to one fleet of containers or servers, and I'll call that the blue fleet. When you start deploying new code to the green fleet, but you don't send any traffic to it. When the green fleet is completely up and running, because that could actually take a while, then you cut over the router to suddenly send all traffic to the green fleet, and then the blue fleet goes idle. You could leave that blue fleet running in case you need to immediately revert. It's much faster to switch over a router rather than wait for all servers to deploy again. If you're using physical servers, these fleets may be permanent, meaning you've got to have twice the computing capacity at any time. If you're using containers, you can bring down the idle fleet after some time and then just spin it up again when you do the next deploy. But again, these are standard deploy strategies that companies already use. Of course, we want to support these best practices, but our challenge will be to integrate these closely into GitLab to deliver even more value from the integrated whole. Integrating deploy strategies with monitoring and our knowledge of the code base, merge requests, and issues. Maybe an alert of a performance problem automatically generates a new issue, labeled appropriately and assigned to the right person, so it shows up in their to-dos. Now I'm going to go off on a tangent for a moment and talk about feature flags. Feature flags allow developers to decouple deployment from delivery while reducing risk. It's usually an in-code mechanism, like an if statement, to conditionally execute one path or another based on externally controllable settings, such as a simple all-or-nothing binary switch, or a more complex incremental rollout based on percentages, like turning it on for 10% of your users, or involving named groups, like company internal or a beta group. With feature flags, code can be deployed into production while the feature is still turned off. So again, deployment is different from delivery of the feature. Features can then be rolled out to internal users, beta users, a percentage of production users, and then to everyone in ever-increasing spheres. This helps facilitate healthy real-world testing, restricting risk to affect only beta customers rather than everyone, for example, so that you get feedback earlier in the development cycle. Validate your ideas quickly. It also helps stay true to the premise of continuous integration, which is that everything is checked into master often and deployed right away. This reduces deployment risk. I'd like to see us work feature flags into GitLab in a first-class way. To be honest, I really don't know how to do that yet, but I know I'd like to see at a glance which features are in private beta, for example. And if a product manager tries to turn a feature on for general availability, they'll be subtly reminded that they should go through private beta first. Companies should be able to set a rollout policy of what percentages things should go through at each stage. If done right, it'll encourage a good rollout process and make it trivially easy for users to follow the flow every time. Now, to bring this back to monitoring, feature flags are another rollout mechanism, similar to one of the deployment strategies, or some of the deployment strategies, like canary deploys or incremental deploys. So we should be able to monitor these, showing some analysis and graphs on them. Perhaps it's a simple list of features and summary statistics about them, indicating if they're performing as expected, like feature X rolled out to beta, decreased response time by 5%. Or feature Y rolled out to 10%, increased conversion by 25%. Anything that you'd want to monitor, we should be able to attach back to the feature and let you know, and then alert on it and give you notifications and emails and whatever. The good thing is that since feature flags often run in parallel, you've got some users with the flag and some users without, so you can more accurately determine the performance or impact. You don't have to rely on point-in-time changes, like looking at memory before and after deploy. And it's quite possible to have multiple feature flags at the same time, all at different rollout stages. With a deploy, which ships everything in master at once, if there's a problem with one merge request 25 commits ago, you've got to roll back the entire stack until that change is gone. But feature flags are decoupled, so if there's a problem in an individual feature, you can just scale that feature down to 0 without affecting any other feature, and without requiring a lengthy deploy process. Another side note, since deployment strategies and feature flags are somewhat advanced topics that currently take quite a commitment to implement, most companies only focus on one of these strategies. If you work on feature flags, you're not likely to bother with canary deploys, for example. But each tool has their sweet spot of value. Memory problems aren't likely to show up using feature flags, since memory is a system resource that's really hard to pin down to a specific user. But error rates or conversion metrics are great for this. If we do a great job here, maybe people won't have to be so stingy on their choice of tools. They can pick and choose whatever works best for them. And with that, I'd like to thank you all for listening and open it up for questions.